Yeah, welcome everyone. Everybody who has just joined the room, there is a Git with the Jupyter notebooks, the slides, everything I'm going to show you, including all the solutions and everything, is already on GitHub. Feel free to download it. So this will be a walkthrough tutorial, so I'm going to mostly walk you through what I'm doing. I'm happy to take questions up to a certain extent, because we only have 90 minutes and we have quite some ground to cover. And then I will encourage you just to play around with what you just have learned about all by yourself. So there will be no programming riddles to solve, because I think it's taking too much overhead, because we want to learn a lot today. So this is an introduction about pandas. Who knows pandas? Okay. Who has worked with pandas? Who is very confident with pandas? What are you doing here? Okay, you're welcome. This is from the background. Who's like a real Python programmer? Who's new, or other way? Who's rather new to Python? All right, okay. But everybody who has experience in one programming language. Okay, all right. Almost everybody's quite confident to programming, so we don't need super programming skills to use pandas. You can basically learn the methods. Of course, if you know basic Python, or even the better you're in Python, the more you can do with pandas, especially if you want to mangle the data. So, okay, let's start. So I'm Alexander. I work with Königsweg in Mannheim. We're a strategic consultancy, and we consult startups and the middle-sized industry. So my domain here is data science consulting. I'm also on the team of EuroPython. I'm the program chair and one of the organizers there. Same for the upcoming PyCon.de in Karlsruhe in October. And yeah, I like to speak and teach and talk. So what are we going to talk about today? We're going to do an introduction to pandas. I'm going to tell you a little bit about the pandas' origin and why is it there. It's going to be a follow-along tutorial, so we're going to start with like a practical, really basic stuff, and I'm trying to introduce you more and more in a little depth how pandas works, how the inner mechanics of pandas are, and how you can make use of them to work with your data. To follow along, to play along with the code, please get this Git now. It's not necessary to follow along with the tutorial. It's handy to have. And vielleicht die URL auf dem Notebook hinstellen? Okay. And we're going to put the short URL here, so in case for everybody who's late, or just take a picture. So can everybody from the back read the slides? Okay. Probably we make the room a little bit more darker. So. Okay, I'll just try. Okay. I think that's better, isn't it? Okay. I hope that's okay for the recording as well. Nah? Okay. Okay. We'll try to solve the light situation. It's very binary here. On. Okay. Okay. In case you have trouble, just download the slides and the Jupyter notebooks in case you have trouble reading it. So what are you going to do today? First, we're going to start with reading and writing data read data in pandas, write data out in pandas. And pandas is often called the Swiss multi-purpose knife for data analysis. Pandas is very happy to read almost every data format you can think of very easily. So you can read CSVs, Excel files, JSON. You can even load data from the clipboard, HTML, HDFS, you name it. If you want to have a full list, please feel free to go to Dr. Docs. And this brings us to our first slide. This is a practical start into pandas. So the first thing is, if you're new to pandas, we import pandas with import pandas SPD. It's a convention. You find it everywhere. It's like everybody uses it. Nobody uses just like import pandas. It's always import pandas SPD. And so we referenced with PD to pandas for the rest of our code. I can try. It's better? I think this will work. Okay, in our data directory, that's just like a directory, we have some files, and this is more like a Jupyter trick. You can use exclamation mark PWD, just like in the Linux console, to see what's your current working directory. And another handy thing is you can also just do an ls to see what's in our data directory. So we see we have some sales data from the Bluth data store, from the Bluth sales data. It also includes a generator for generating fake user data, which is quite handy. So the first thing we're going to do is just like get one of these CSV files and read them into our pandas data frame. And what the data frame is, and all this I'm going to cover later. So just let's imagine it. Let's read this into a table, and a table we can work with. So all we need to do is call the read CSV method, pass in a file path, and that's basically it. And let's explore our data set. So this is what we have. Smaller. So, okay, doesn't matter. Okay, this is basically our data set. It's all built in. That's the magic of Jupyter. All we need to do is just basically print sales data to the screen, and we get this nice print of what we have. And that's basically it. That's one of the simplest things you can do in pandas. A few things you probably already see. We have a header file in our CSV, and the header files are automatically used as column names. We also see this thing here on the left, which is not in the data. That's called the index. We're going to talk about that later. But basically, it's quite simple. Since this is a little bit too long, let's reset this. That's just another thing you can just do on the fly. We can just set an option for pandas to display only like 10 rows. We want, and so it's a little bit more fit. And we also get information our data set has like 1,000 rows and 7 columns. So, and let's see, what do we have in sales data? Let's do a little bit more exploration of what's the type. So the type is a pandas data frame, as I mentioned already. It also has a standard length, which is 1,000. And we can also inspect, and that's very handy. And if you work with Jupyter notebooks, it's especially handy if you want to explore a data set. You can iteratively explore the data and see what you work with, you can just use the head function, just like in Unix systems, on tail. So head will, you get the first 5 lines, tail the last ones. And here we're going to a little bit deeper. We also have an info method. And what does the info method gives us more insight in what we actually have in our data set. So we see here we have a name, 1,000 objects, 1,000 entries in each and every column. And we see most of them are objects, but we already see units and unit prices with integers and floats. And basically, I just read in a text file, and pandas figured out the rest here, which is one of the great powers of pandas, but probably something, depending on the data quality you're reading in, something you can also have to fight with pandas, or basically not fight with pandas, use pandas to fight with the data you're reading in to get what you want. So what we can note here, everything, for example, let's go a little bit more up. We have obviously the birthday and the order date. This is like a date and a timestamp. And if we just use the standard methods here on the CSV files, they're still stored as object. So it's not a datetime object. Objects and pandas is always like a string. So they're still stored as string. So date strings are not that handy to really work with. So let's see what we can do about it. So we just use the same method and pass in one more parameter, which is actually parse dates. And in parse dates, we pass in the column names of the date time columns. And the thing is, pandas will figure out the rest for us. So we have a new sales data frame now. And as we can see here, the birthday is now a datetime, and the order date is now datetime. So this is super handy, and it's also highly customizable. So what we see here is still the same. One caveat, something you have to keep in mind. We did not do any instructions how our dates are actually formatted. So we can give instructions. We can also change the data later. So I'm going to show you later. But there's also like auto parsers included in pandas, and they're really good in guessing what the best format is. But they are not perfect for every data set. And for example, the datetime parser is very US date friendly, and as you probably know, the US is the only country in the world which has month, day, year format, which is a little odd, but it's friendly. You can be more explicit here in pandas. You can also pass in just like day first true. So day first true says, oh, we have dates with the day at the very beginning. And this is sorted out automatically for you then. But keep that in mind, especially if you have a data set which dates beginning of the year. It's or like with lower day numbers. It can be really tricky, and you end up with like really crazy dates. Okay, so we've read our first CSV file. It's quite happy. It's quite easy. Just let me. I don't want to really go too deep into the methods, but I encourage you to read it by yourself. For example, I think the read CSV method has more than like 40 parameters you can pass into, and this is going to be quite overwhelming for a beginner because there's a method for everything. I myself, I was quite happy to find. I recently found something. There was no method built in pandas. I was very happy. Just read them through. Don't panic. Stay focused on the problem you want to solve, and also you don't necessarily need to solve all your problems on importing the data already. You can mangle with your data probably in a more flexible way later. And I'm going to show you a little bit later how you can mangle and work with your data once you have them your data frame. So there are many methods. Yeah, this is, by the way, a nice application. It's called Dash. It's good to store offline documentations. Since I travel a lot, this is really handy if you want to look up on the plane or something like that. So let's go back. So JSON, let's read in some JSON. And this is, of course, very simple. All the read methods are very, very similar. So this looks just like quite the same. And let's see what we have here. Again, everything is imported as an object, but I'm a little confused because like JSON has a standard datetime format. It provides actually a standard datetime format. Still, Pandas tells me it still imports it as an object, and the reason is in our sample data set, the datetime format is not it's not ISO. It's not in the ISO format, so it's a little bit more free format. So Pandas does nothing here. It's also right. So we have one approach, really solve it, which leads us to the next input method. We can also just like read in the JSON. So this is our JSON. We see here we have an order date. It looks nicely formatted, but it's not as it's supposed to be in JSON, which is something like this here, like with a T in the middle. So, and of course we can do all this cleanup and making it into datetime ourselves. And of course we can also just use the JSON we read in. Then we have a dictionary, and now we change the datetime format in our dictionary. So this is just like a Pythonic sideway we are taking here. And of course, we can also read data just like from the dict into JSON. And this is what I'm actually going to show you here. So, so we have sales data from a dictionary in Python. So it's also Pandas is really handy if you have data in Python and you want to mangle it or export it to a CSV file, for example. For example, there's also like the CSV library in Python. I had to use it in early days. Nowadays, I only use Pandas for it because it's much more handy and powerful and simpler to use. Yeah, so we see here a birthday. We changed the datetime, we changed the format to datetime in our JSON, so this works correctly now. But, yeah, this is basically, yeah, that's just like one step what we did before. Probably a little bit more efficient here is to use the convert dates method, where we can also a parameter which we can just pass in birthday and order date columns, and Pandas does the rest of the heavy lifting here. And let's look at our info, whether this was successful. And yeah. And I encourage you, if you read data in, really use this info method. It's really handy to see what's in your data set. Like also, I'm going to explain a little bit more later about why the date type in Pandas is important. And it's because usually Pythonistas, we don't care about the types. Python does most of the stuff for us. So, but in Pandas, it's one of the things that brings all the performance to Pandas. And we also have a describe method for our data frames. And the describe method is more like basic statistics about our data frames. So we have a count. We have like 1,000 rows where the mean of the unique price and the units. We have a standard deviation, a minimum, a maximum, and the quartiles here. So if you want to take a peek into your data, it's really handy. Just read in the data, the describe method, and you already have an impression, so what's in your data set, whether there are probably outliers there. So if you have, like, if the maximum is very far apart from the mean. Yeah. Okay. Here we go. So, and of course, if you have to deal with sales reports or like classical industry, like they still love Excel a lot. And actually, I was never so fond of Excel, but recently I really fell in love with it again because it's really handy. Actually, you will see in a bit. So we can also like work with Excel. Guess what? You can read the data just in, like by giving it a path to the Excel file. But one nice thing here is you can instruct which columns to pass. So in Excel, you know, like all the columns A, B, C, D, D, D to wherever, and then the rows are just like numbered. We can also like just take the first two columns. So for example, if we want to see who the birthdays of the people we have in our data set, we can just like immediately instruct pandas only to get those two columns and into a data frame. And here, that's a nice thing about Excel data. We see the birthdays already datetime because internally Excel supports datetime. It's stored as an integer there. So we don't need to mangle any stuff here. So we're going to do exporting to Excel and exporting to CSV, DIGT, and everything. I leave this up to your imagination because it's basically the same, except for some parameters you can pass in. So it's really easy. We just pass in a file name. We have, for example, index false here. Because we don't want the index exported in an Excel file. I just want to have the columns here. And we can also name the sheet data. And yeah, the Excel is now saved here. Leave it to imagination. Let's save some time. Why did I recently fell in love again with Excel? When we were building the EuroPython schedule, so EuroPython has like 200 talks with like many constraints, people, speakers, availabilities, topics should be grouped and all this. This is a really hard problem. There's just like too many ways to solve it. So actually, I built a piece of software to do all the heavy lifting in the schedule, and then it was really hard to, I wanted something to visualize everything. So I started exporting our schedule to Excel, and this is just like a picture as an example, where Excel and the close connection to pandas can be really strong. If you use the XLS writer library, you can basically make this your pandas Excel writer. You can even you can put colors, like the column sizes, row heights, everything here. And this was really handy because it was very simple to set up. And for example, we have the data stuff, which is red. DevOps is like lilac. And so this was really handy to do some useful, simple report for the program committee to decide this is a good schedule, or should we work on this a little bit more? So this is a hint for if you work with Excel and you really want to export nice Excel sheets, which makes your colleagues from other departments happy. Look into the XLS writer library. There's a really good documentation there with many examples. It's quite simple to do. So let's go a little bit up here, and let me just so I just mark it and I just copy it to my clipboard. And this is also something which can be really handy if you get structured data from another source and you can just copy and paste it. You can even just copy and paste it into pandas. And of course it does not always work that well because it has to be not everything is understandable. Let's give it a retry. So okay. Yeah. So I copied these two lines and I read it into the clipboard. Of course, pandas is just checking whether it's possible. It will easily break if there's just half a column missing or something like that, or if the data is well formatted. But for example, if you have something from SQL queries or so, it's super simple to get it into your clipboard if you want to just like work iteratively. So that's already the end of our first part of the first session on getting into pandas. That's the end of our little light warm up. So what we've learned, reading and writing data in pandas is really simple. It's very customizable. It can be overwhelming to beginners, so don't be too overwhelmed. Just like concentrate on the problem you want to solve and look for a right parameter to solve it. A lot of the handling is done really well by pandas by default, so you don't need to configure a lot of the stuff. On all this very much depends on the data quality you read in, and basically many times you have to fight with the bad data quality you probably have to work with, and and pandas can be your friend. One of the caveats, we haven't seen this here because there are no null values in our data sets, but something which is sometimes a little confusing for beginners. If you read in a column with integers, or you expect integers, and they're imported as a float, it's because there are nan values in there, because only a float data type can handle nan values. Just keep it in the back of your mind. And yeah. So, yeah, this is just like a little summary. Any questions? I think it's quite easy peasy, just warm up, so you're warm to do more stuff. So, where does all the power come from, pandas? It's basically, that's why it's called Ode to NumPy, because pandas is built on NumPy. NumPy is a numerical library it's the library for working with numbers in Python, and that's where all the power comes from. If you know Python, Python is dynamically typed, so you don't really have to define types as in other programming languages before. And but of course, dynamic typing is taking performance, because while your code is running in the background, you always have to recheck the type, what's happening, guessing, and all this stuff. And so NumPy is typing the data. So we're going to see a little bit more and I show you a little bit more about the data model, and also a little bit more about definitions. So if we talk about a table, tables are often referred to as data frames. We have columns and rows, even like within pandas, and there's data series and data frames. And let's have a little bit more a look into the structure. So our data is just like a NumPy array. So this is just like an array of integers, for example. This is like a list, but this is a typed list. And there's only one data type in this list allowed. So it's not like in a Python list where you can have strings, integers, whatever are mixed up in your list. So there's only one data type here. And okay, we've already covered this. We have our NumPy array here. And a pandas series is basically a labeled NumPy array. This is just like a one-dimensional array, so you have the data and an index. And for example, here the index is positional. Should actually start at 0, because we have 0 indexing here as well. And when you work with pandas, it's a little bit, it's very important more to think in series, and these series are like verticals. And because if you work with data in a table, you usually would rather think in rows. You iterate for each and every row. And of course, there are methods in pandas where you can basically take your data frame and iterate over the rows, because it's better for our heads. But if you want to get more creative and have a neater and much more pleasant way to work with pandas, really try to think, okay, this is a series, and this is just like one series, and of course, multiple series with the same index is a data frame. So basically, the index is the link between the series. And that glues like everything together to a data frame. There's also another thing, three-dimensional object, it's called panel. So if you stumble across it, you know, oh, Alex told me about it in Berlin, but you can already forget about it because it's been deprecated, because we can use multi-indexing for now for this. So all we need to do to remember here is one-dimensional data series, and a data frame is a two-dimensional one or more series, or even one or more data frames. So, from the definitions, like synonyms, we can say table is a 2D data frame, column is a data series, a row is all the values at the same position in each data series in a data frame. I would have loved to come up with something more compact, but that wasn't my best shot. So let's have a deeper look into series. And it's all the same. It's also in the notebooks, but since I have added some extra stuff here for visualization purposes, we're going to use the slides here for the tutorial. So, how do we create a data series? It's very simple. We could just call the series method, PD series, and here we just pass in 10 random numbers, and this is our result. And we see already, we already have a data type, because we asked for a random int from random, and a positional index created on the left side from 0 to 9. So we have 10 values there. It's very simple. And how can we access data in a series? So we only have a one-dimensional, we only have one row now. And how can we access it? We can access it by position, just like as we can access lists in Python. So if we pass in 0, we will get the first value. And see, there's always like our series on the right-hand side, so you can follow along a little bit easier. We can also do slice, as we do with Python slices, from like 3 to 6, and we get this. And there's also the ilog method we can use. And please note, square brackets. Yeah? It's not the method, yeah? Use square brackets for ilog, and we can do the same. So ilog is basically like an integer location. So you can pass this in here. So, but as I told, yeah? Yes. So log go. I'm going to cover it in just 10 seconds. Thank you. Yeah. As I told you, like you can imagine like a series as a labeled. It's a labeled array. So let's set an index. Don't worry what an index is. So we're just resetting this to letters. So, and now we can still do the slicing on a series here with the position, just like the Pythonic way. We can even do slicing with passing in labels now from D to F. So, is Pandas super magic? Can I just pass in any slices? No, of course not. You can only slice for one block, which is like if there's one value after another. So too many slices will fail. We can also concat, for example, if you want to have like the rows D to F and I to J. The better solution is to use the concat method and pass in the two slices here. So you can get this here. And now I guess we come to the log method, which was just asked about. So of course, with the log method, we can now also pass in a label. And for example, the label here is, in our case, a string. So the log method will look on the index. The ilog method will always go by the position. So, and it's really easy to ilog integer and log label and I integer location. So it's quite easy to remember. The log method does not, it supports slicing, but something's different here because I set a new index. The index is no longer A to J. I passed in Gattaca. there, Gattaca X, Y, Z, and I can use the log method. I cannot actually use it to get from G to A, because the index is not unique, and that's one of the learnings of the pandas index. Pandas indexes are not necessarily unique, so especially if you're, just a second, yeah? Oh, it just, you were just stretching, or? Yeah. Ah, okay, yeah. Yeah. Oh no, G is 6, so like the first G is the value 60, yeah. Oh, I'm sorry. Okay. I have to fix the slides. I'm sorry. Look over there. I'm sorry. Oh, thanks for pointing that out. Okay, but here we have X, Y, Z are unique in our values, and here the log method will work. So, so this can be a little bit confusing for beginners, especially if you don't know about the index, and this is why I'm covering the index at this quite early stage, because I think it's one of the most important things to understand in pandas is actually the index. So actually, yes?
So how does it infer the sorting of the index when you pass like numbers?
No, actually, this is just like I just take, this is just like a list comprehension taking each letter for renaming. So it does not really sort if I don't instruct the series to sort explicitly. So it's.
I mean, how does when you do the log method?
Yeah.
And you pass the index, how does it know what's between the two indices? Does it just have the list in the background and then convert it to some position?
Yeah, actually, like it looks up in the here you see when the index is unique, it knows where to look, and you can see like is there a match. Yeah, so in between, but it's not necessary. I think we could exchange the Y for anything there.
So when I smash up the indices,
yeah.
the log G to A or A to B when so when I have an index A to Z,
Yeah.
and I smash it around somehow,
Yeah.
and I do log A.
Oh, I get it. Now, the order in the index is used for the slicing. It's because it's not caring about is this like an alphabetical label. It just looks for the label, and until it hits the next, the end of the slice. So it's still not intelligent. So it's just like iterating and sees what the slice can be. So the index. So actually, like as I mentioned, like the label of a series is usually called the index. It's automatically created if you don't give it when you're importing your data or create your series. As I already saw, it can be re-indexed, it can be replaced. It's immutable, so you can just like decide, oh, I have these duplicates here, just like go to the position and change one index value. You have to reset the whole index then. It only can contain hashable objects, so integers, tuples, strings, but of course not sets or dictionaries. It can have one or more dimensions. So today we're only covering up to 2 dimensionals because we don't have time. And remember, the pandas index is not necessarily unique. So there's multiple index types, which I'm so sorry we cannot cover them all. There's the index, the multi-index. Multi-index is basically used for groupings a lot. There's a datetime index. It's my favorite index. Talk about it a lot. We have time delta index and a new categorical index, which was just introduced into pandas with the latest version, and an interval index, but we cannot cover them. So let's go on and see how can we select data from data frames. So we have a data frame. It's now 2-dimensional data, and we see we have 10 data series as columns and 10 rows with some random integers. And let's see how we can slice them. So we can just access, if we now use a data frame and pass in just like an integer, we don't get the row, we get the column. Yeah, this is very important because, as remember, with the series, we got the value from the series, which is actually more like the row. It's just like a row with one value, but so if you select on data frame, we select the columns, the series. We can also slice, but this is then very confusing. If you slice and put in like a range here, we get the rows back, which is, I think, a little bit logical break here, which you have to get used to, which can, as I said, like, can be confusing at the beginning. So we also have an ilog method here, and the ilog method, we can also select the segment. Probably you can't see from the back. Here's like 4 here. Well, I use the mouse. There's like mouse. Okay. Yeah, that's like 4 values selected here, and then we have to pass in, of course, like 2 to 4, which is actually like for the 0 axis and the axis 1. And I'm going to explain you and give you a hint how to remember about the axis here later in a second. So we also have an ilog method, and the ilog method, yeah, basically it's also like the same. So if you want to use the ilog method, the first is axis 0 is the rows, so we pass in just like for everything, like we can do in Python, just like it's a range without start and end, so everything. And the second to the 4th column, and this gives us X back. And so I really have a lot of hard time in the beginning to axis 0, axis 1, what's this? So let me explain. So basically it's very simple. Axis 0 is the rows, so it's a horizontal. Axis 1 are the columns. And since I'm one of these guys who always like mixes up left and right all the time, I found something to remember. So this is my what we call Eselsbrücke. So the axis 1 looks like a 1 because it's vertical, and this is like a good way to remember, oh yeah, 1 gives me back the series because it looks like a 1. Okay. Next. Indexes. Indexes and column names. Of course, when we created the data frame, we only had just like positional values here. Of course, we can just like create it. So I'm just resetting the index to start with R and have like 2 digits. Same for the columns. So we can just like rename them. Really simple in Pandas. The selection here is the same, so we can just like pass in CO5, which will give us back the label. We can pass in a range, and remember, ranges on data frames go for the rows, not the series and the columns. We can also use a range here. It works with the same logic. We just have look deeper with a getter. We can also use the log method to get a slice of in the middle of our data set, which is just like following the same logic here. And now we come to something which we kind of call Boolean indexing. So, and let me see, yeah. Sorry, skip that. Boolean indexing. So what is a Boolean index? Boolean index has nothing to do with the indexes I just mentioned. It's just like called indexing as well. So we see these are the this is the data we have in our CO4 series, and we can create a Boolean index very easy if we just pass in like get like the series greater than 60, and what we will get back is the series with the same labels, and the values are just like true and false. So this is a Boolean index. A Boolean index is just like an array of yes, no, yes, no, yes, 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 no, no, no. And basically, if we combine our data and the Boolean index, we only get the data back where we hit a yes. So This is all the magic. So if we pass this, the Boolean index we have up here in the outer square brackets. We can just pass it in, and it returns us back all the rows where C4 is greater than 60. And we can also do combinations of this. So we can pass in an OR, just like with the pipe in the middle. Note, we have to put brackets around our Boolean indexes here at the beginning, like the smaller 60 and greater 60. So this is just like we can select anything else which is smaller than 60 or greater 60, get back the rows. We can also do multiple ANDs and pass in like anything which creates a Boolean index. And this is one of the things that comes in with NumPy is the broadcasting. So if you work with vectors, you know, like you can like take one vector and multiply it with another. And this is like the same works here. So we can just like pass in, okay, gives us back the everything where the mod of the value of mod 2 is 0, and we only get these 2 rows in the end. So yeah, to speed a little up because we only have 15 minutes left. So yeah, now you're familiar with data selection and indexing on data series and data frames. Please keep in mind the selection on the data series and data frames. The slicing is different. This can be a little bit confusing at the beginning because you're probably not always aware whether you're really working on a series or a data frame in the very beginning. Also, when you select data, you always get a copy of the data return. So most of, like all the operations you do on data frames are not applied to the data frame until you explicitly instruct. So we will see that in a minute, because when we come to operations. So operations, I want to show you how can we add and remove series. Do stuff like adding, subtracting, mangling the data, and how can we be working with null values, which are n and n. So let's go to the next here. Okay. Yes. Yes, you're right. Oh, I'm very relieved now. You're right. Thank you. Probably should have put my what? Oh yeah. Oh yeah, we have 42 minutes left. So, okay, let's do some exercises now. So, okay, yeah. Well, since we have 40 minutes left, thank you again. Questions on selecting, indexing, or anything else? No? Yep. Columns, or it's just let me go. Okay, yes. The question was can we index columns? So actually, columns are not indexed. Columns have names, but we can just let me go back a bit. Let me show you here. Here, on the top. Here we reset the index and we set the column names just like passing in a list of the names we want to have there. The Boolean indexing. Oh, the Boolean indexing. You mean like Boolean indexing for columns? Why not? That's a really good question. But yeah. Is it? Yeah. Yeah, but how can you? I think you basically, if you work with series, because like then it's rows. So basically, you have transposing is probably the best thing, or just like get the series because like why you transpose a column like? They know why do you want a Boolean index for the column? What's like the use case you think of? You can also like select the columns just like by the names if you want to. Okay, yeah, okay, yes. You can just like select one or multiple columns just like by passing in a list of the column names. Oh, yeah. So you don't need to Boolean index for this.
if you want to use Boolean indexing for columns, you could just do a list of your columns and do Boolean indexing on this one. Then you could give the list to your pandas data frame. Then you get Boolean indexing for columns.
Yeah. For example, yeah. So actually, I've never stumbled across. I never had a need actually. So, but thanks for bringing it up. Yeah.
I just wanted to ask, if I select one column,
Yeah.
is it automatically a series? Because they are
Yes.
so I don't
Yeah.
need to convert it to a series. It
No.
becomes
If you
a
select
series.
a column, you get back a series, also including the labels. Okay. So the index. So all the index comes always back with it in the background. So. All right. Cool. So. Where were we? So it's. Okay, so what can we do to mangle with our data? How can we work a little bit more in the series? That's what I just like sum it up with operations. So let's get our favorite data set back into memory here. It's stored in a df for a df data frame. So we can also work dynamically with our data frames, so we can add columns, delete columns, select rows. So, for example, if you, for example, just select a part of your data frame, you always get back a new data frame or series if you only want to select one series, and you can work with that data frame or series as with any other series you created. So basically, if you have a huge data frame, it's very easy to go to use pandas, just to slice out a part of the data frame and work with it without changing anything else. Let's just add another 11th column called C10 to our data frame. That's simple. So this was, as you see, this was just a list with the same size, 10 numbers we added to our data frame. So as I just explained, it's really easy to take a series out. Is it also that easy just to create a new series and pass it in? So let's see. This is what we're going to do here. So here we create a new series with the pandas series, and I pass in the same list with 10 integer values here. And now we have a new series. So let's have a look. So this is our new series, and let's just add this new series to our data frame. Why did the stupid Python list work and our super sophisticated pandas list not work? Ideas? Index, thank you. Yes, of course. Because when you add data, pandas is, if you add series to a data frame, pandas is actually looking at the index. And since we have these R0 to R9 labels on our index, here our new series had just an auto index, which was just positional index from 0 to 9. So of course, this did not work. So if I want to add a series to my data frame, I have to basically just do an index here, and this is what I'm just let's make it an extra step. So here we create a new series, and it's really easy to just get the index from our data frame and set it as the index of our new series. That's very simple. Of course, this has to have the same length. And so, of course, this is really easy to set. You could also, for example, you can also add. We're not going to cover joins here, but for example, if you have like a smaller, we could also use like a series with like only 6 values. For example, from just like R00 to R05, and add these to our data frame. So it's not necessarily they have the same length. Of course, pandas would then add NaN values, just like we saw here. So we would have like 6 real values here from our list, and the rest would be automatically null values. So this is really easy and handy if you have to join data from various sources. If you have labels, corresponding labels, it's super easy to get everything together in one data frame. So let's add this as another one as 12 here. How can I get rid of it? So I want to have my data frame smaller, a little bit more readable. So there are many ways to do this. One is just to use del, like in Python, del, and just like remove the series from our data frame. So just remember here, we go up to 10. What happens, of course, if I pass in a column name unknown, we'll get a key arrow. But if we're not sure about whether we have columns in our data frame, we can also avoid key arrows if we use the drop method and just like instructed to ignore errors. So we can just like drop any column by name with the drop method without raising errors if the column is not present. That's really handy if you get data from outside and there's different column names there. And of course, if you want to have like just like a smaller selection, if you're just like interested in like, for example, like 2 rows of your data frame, there's no need to delete all the others. You can basically just like create a new data frame with the log method and just like instruct it, give us back all the rows here and just like these 2 columns and just like store it to a new data frame or overwrite the data frame variable you're working with already. So this is very easy. And how can we mangle the data we have in our data frames? So let's do a little recall on NumPy broadcasting and what that is, basically. So we just create one array, A, here with like 3 values and another one, B, also with 3 values. And broadcasting is really simple. So we have these 2 arrays, 3 values each, and if we want to, we just can, for example, just add them to another. So, and of course, like the values are added according to their position. We can subtract them. We can multiply them. We can divide them. We can even like just like add a constant to it. So since there's only one value, 7 will be added to each and every value. This is just like broadcasting. We can also divide it by a full integer here. So this is all 0. Of course, we can also just like multiply it by another array. So yeah, this is the idea of broadcasting. I think everybody got the idea. And the same works comes at hand if you work with pandas series. So imagine you have series and there's like multiple values, and there's often stuff you want to do with these values. So let's get back to our sales list, the sales list from the Bluth store. So this is just like some customer data. So we have a customer, the customer is a company. We know the first name of the person who purchased it. We know their birthday. We have an order date. We have a product name. These are like the 10 most successful products of all times, according to some internet list. We have a unit price, the price we asked when the item was sold, and how many units the customer ordered. And this is just like random data. Let's see. So, for example, what we are missing here is, for example, management asks us, okay, what was the turnover? We say, okay, yeah, we have a unit price and the units, but we really miss a turnover data. So let's add a new series called turnover to our data frame. So this is our data frame. We add a new series. We label it turnover, and we just can pass in the two series, unit price and the price which we actually asked, and just like multiply them. It's as simple as that. And now we have another series in our data frame for turnover. And now we can also ask more information. For example, what's the mean? What's our mean turnover? Or for example, probably even more interesting. So we see we have all these nice methods. We can actually all apply them directly on. Let's copy this. You can. Over. We can also just like easily get the sum of our turnover of our data set here. It's all built in. We can also just ask what's our medium turnover, and of course we can also have a closer look at our data with the info method. So, for example, we can also work with the data we have in our series in a very flexible way with, for example, the map method. So a map method here is just like in any other programming language. A map method is map this and take each and every value of a list and apply a certain function to it. That's a map. So what are we doing here? We want to create a new column, just like what the year the purchase was made. So we take the order date. We know here the order date is already a datetime object, so we don't need to do any data conversions here. And we can pass in a lambda function. So all we do here is take each and every value, datetime object, and just like ask for the year of the datetime object, and we can just access it directly with .year in Python. And this is what we get. So we have the year now. The same we can do just like for the month. And in case we are interested in getting some easy report for year and month, for example, to do a plot or a report or a summary, we can also combine multiple columns. So we're creating a new year-month column, and we can just pass in the two series and basically concatenate them with just like by adding one to another. One thing here, the year is, of course, we cannot just like, Python won't allow us to take an integer and add another integer to do, and because we were looking for string. So what we do here, we take the data from the year, pass in map, just like string. So each and every value in the series will be converted to a string. There are other methods to do this, we will see in a second. And of course, we want to have like a two-digit month there, nicely formatted. And it's as simple as this. And now we have our year-month column. One hint, if I wanted to create a sales report on year-monthly basis with data like that, I would not do it like this. It's good to do this if you're new to Pandas, if you want to have your data really visible, but this would be a super cool case for the datetime index, which we won't cover here today. just like as a hint. Yes. The difference is that, oh yeah, sorry, thank you. What's the difference between map, apply map, and apply? Map, actually, basically, just was about to explain here later. Map is for a series. Apply, you can work on a data frame with that, and apply map is basically you can apply it to the whole data frame. But as far as I know, there's no big difference anymore between apply and apply map. It was only in the beginning, because I think if we do this here, we will get the same result. So as we see, this was just basically applied for the whole data frame, and if we only use apply, we get the same. I'm not 100% sure. It was only, I think there was only a difference in the early days. I think it was merged into. Yeah, as we see, we can also apply lambda functions to a data frame. So we can just like get a subset of our data frame, just like the two columns, and apply anything to them. For example, divide them by 1.5 or whatever we want to do. But as you see here, this is because like very often forgotten in the beginning. Here we have sales data, we select two, we apply something, we get like new values back, but if we look at our data frame, nothing has changed. It's really important to know that Pandas always returns a copy of the data, and it does not apply all this directly in the data frame unless you instruct it to do so with the in-place method. So you can do something to a series, pass in place true, and then your data frame will change. Otherwise, you can also just like reassign a variable for this for your data frame. That's the same. Yes.
Why would I use math if I can just use regular like expressions? Like you said, with the broadcasting, that number I give you.
Actually, like that's another thing which is very overwhelming. There's not only one right way to do it. There are many ways to do the same in Pandas. So it's basically it depends on you. Yep.
I was always assuming that using broadcasting must be faster because it is handed down to implementation. Is that right, or
Probably. Actually, I've never worked that much in introduction. Oh, okay. Thank you. Yes. Wow. Okay. Why is broadcasting faster than applying a method? So, and actually, honestly, I've never measured because most of the times I'm not really worried about like getting the most of the performance because Pandas claims itself it's good for handling data up to 1 gigabyte in memory. So and I handled bigger data sets in memory without really having any troubles with it. Pandas always is fast, and I have probably I used to worry about performance in the beginning a lot in earlier days, and nowadays I just say I only worry about if I have a performance problem. So there are methods to use for like bigger data sets, but we won't cover it in the introduction here. But there's some nice, I think, from Tom Augsburger, there's some nice tutorial how to work with bigger data sets if that's, and I think he's also like, there's also an explanation on the performance differences.
I have another question.
Yeah.
Are there functions to perform computations in place directly without copying? In the are there functions to perform the computations in place without?
Yeah, you can pass in place, and then your data frame will change. Yeah, so that's important. So usually, if you take some data out of Pandas, do something with it, you always have a copy, but you can also instruct it with in place true. Equals true to apply directly to the data frame. Yeah. So Here, we also have a describe method on our whole data frame. So we can see the same statistical data we saw for earlier for the series with like count, means, standard deviations, minimum, maximums. Here, and of course this works also for the series still. So for example, also for like a daytime series. So we see we have 284 unique birthdays within our 1,000 people we have here. And the most popular, this is the most popular birthday. That's the top birthday. So what else? So for example, we have now floats in our turnover. We can also easily change the type of a series in Pandas. We can just pass, if we want to replace it here, we pass it into our, this is like the replacement here, we assign the new turnover with, we get back from as type, and I want to, oh, okay, thank you. So I can just like say, okay, make this like an integer, like with numpy integer, or just like pass an int. And this will return the float value as integer, and we just save it back to the data frame. And one thing is, especially if you get data from the outside, or which is not like clean or not as you want. So let's sneak in some null values. So as we see, we have now null values in our data set for the unit price, and also for for the order date. So this is not a timestamp then. So you can check your data frame if there are any null values there, because sometimes if you pass in like a more special function, this might lead to an exception, and we don't want that. So isNull gives us back any row where we have a null value. We can also just like drop the null values from our data frame. So we see we've lost some lines here, but remember, this is also the drop NA method returns a new data frame. So this would be a super good place. Oh yeah, I'm showing here, in a second. So this is just like a copy from the data frame, so nothing has changed. The same is for, we can also pass in with fill NA default values. If we want to, if we know, okay, better guess the data or have a 0 there or something like that. You can also be like more sophisticated backward fills, forward fills. We won't cover it here, so you can even like write your own interpolations for this if necessary. But as we see, our data frame has not changed. So this is again an example for the in-place method. So here we do fill our NA with 99.99 and for every null value we had, in place true, and as we see, now actually our data frame has changed and every null value is replaced. And as you can see here, also the NAT values will be replaced by this. So there's no difference, so because this was NAT displayed as a non-NAT before, and so we're now like in the 70s here. It's a very early order. So, okay. To sum this up, you see how you can apply, map, mangle your data, working with NaN and all the stuff. NaN is a representation of null values. You can have to replace them, drop the lines. It very much depends on the data set, your work, and your needs, how you want to handle null values. Sometimes you can drop them, sometimes you need some default values here. So, and modifying data series and data frames is very important to know. You always get return to copy, and of course I'm emphasizing it a lot, because it's often forgotten, and with a parameter in place, the result can be applied directly to the data frame we are working with. So, where we are. Here, okay. Okay, any more introductory questions on this? Yeah.
In the fill NA method, is it possible to write some conditions such as if the turnover is less than 500 or 1,000, fill the null values with this number, or fill
You
it
can
with
write.
that
You
number?
can write a Python method
Okay.
as you wish, and just pass it in.
So we need to include this fill NA inside those if conditions or else condition, not like. I was asking something like fill NA inside the brackets.
Probably.
Can
I'm not sure whether the fill NA will do this. Probably will. I think so. Actually, I have to look it up in the documentation whether it's. But it should accept the method as well.
Okay.
If not, you can also do a map on the series, and there you can definitely pass in any custom functions you want. And if you hit a NaN value, you can also check the value if it's a NaN value, and then apply whatever you want in a very custom fashion.
Okay.
All right, then as the last part, that's just like a sneak peek into visualization and grouping. So Pandas always comes built in with many simple visualization tools, and it's also very easy to customize them. That's all handled by Matplotlib, and there's also like many libraries involved. Here, for example, this is just like the instruction to plot within our Jupyter notebooks, if you haven't seen it before. So we read in our sales data. Again, calculate our some turnover here. And now we do a grouping. We want to visualize a little bit a sales report. So let's do a group by, which is a very simple aggregation. You probably, if you know SQL and stuff, it's the same. So we just take one key, which is the product's name here. And we want to group it by the product and basically get the sum back. And let's just have a look. And here, that's basically it. So important here, we do a selection of the columns we want to work with. It's just like the product and the turnover. The group by is done by the product. This group by will only accept, of course, columns which are selected. So we could also take the whole data frame here, so this is not absolutely necessary. But for example, we would not be really interested to get the sum of the unit price here. That's why I'm doing a pre-selection, because the sum of the unit price is quite pointless. So and then we store it into the TT variable here, and then it's really easy. Then we can just like take our take this and just do a bar plot, and we can just like take the data frame or the series or a series, plot it, and add dot bar for bar, or we can do the same for the mean. So if we or the units sold, sorry. So this is a new grouping about like how many units are sold, which is a little bit more nicer to plot. So we can have it as a bar plot. A nice thing here is, of course, we also have more plots built in, all for Matplot. What a nice thing is, you can still work with these plots. So it's not just like take this, plot it, and that's it. So the plot returns the AX object from Matplotlib. So, and you, basically that's the plot object, and you can still work with it and improve it. For example, here I was interested in, okay, what's the median of the units sold, which is quite obvious here. So here we can just like take the AX object we get back, so save it in a variable called AX as well, and just use, bless you, a horizontal line here with a method from matplotlib directly. And here we just take the units we have just aggregated, or take the median of them, define a color and a line style, and just like immediately add it to the same plot. And another nice thing here, it just looks too simple. All the labels from your index and the data you work with are automatically added to your plots as well. So this is really handy, because in earlier days, all this plotting was a lot. You had to do sometimes a lot of customization on it to have a nice plot. It's understandable for outsiders and not familiar with the data set. So here Pandas does all the heavy lifting for you as well. Okay, let's just like see a little bit more about what we can plot or aggregate. For example, this is just like a not so useful plot. So by default, we get a line plot back. And also, if I group by each and every day or order date, which is the timestamp actually, it's not very readable. So is there something we can do about it? And finally, I get a little bit more to talk about how handy, for example, the time series index can be. So we here have our sales data, and we reset the index now to the order date. The order date is a date time. Yeah, sorry, could you please? Thank you. Is the order date, is already a timestamp, a datetime object, and so we set our index now to these datetimes objects. And this creates my most beloved datetime index. And so this is what it looks like now here. So we had some positional values here in the beginning, and now it's a datetime object, and now we can do something really nice. We can take our sales data, group it by the sales data index, year, and week, for example. So the datetime index you can directly access the data year, day, month, quarters. You think about it, it's like a list like this. Thank you. And so here we group by index year, and the week. We want to look into the week, take the sum and just like plot it. And this is basically for each and every week. We get this plot back. You can also use other libraries, for example, like Bokeh or Seaborn. For Matplotlib is you can customize Matplotlib really easy, as I just demonstrated a lot. For probably like Seaborn or Bokeh are more suitable if you want to have interactive visualizations, but that's probably enough for a tutorial by itself. And this is like the last example. For example, here for grouping and immediately plotting the data out with Matplotlib is just like, we can also just like see how is basically like the distribution of our sales across weekdays, and we even can group by them with our datetime index here and plot it to a pie. And I would say just have a look at the documentation to see all the...
Sorry to cut you off, but we have to get ready for the next tutorial.
Yeah. All right. So, yeah, that's also, I was at the end anyway. So, thank you very much. Yeah.
Time for questions now, but I'm sure the speaker will be available outside or later in the conference.
Feel free to ping me or talk to me. Thank you.